Hello everyone, how are you all? I hope you are keep fine, and after a long day I am coming take a class of your next chapter is your chapter number 9 and the study of compound ammonia. So today we will discuss about the ammonia and also discuss about the formula, structural formula and the method of preparation of ammonia and then physical property and the solubility of ammonia. And the last I will discuss advantage and the disadvantage of ammonia and also discuss uses. So get on topic. Okay. Chapter number 9, ammonia, the study of compound ammonia. You know very well, ammonia is made up of nitrogen and hydrogen. So its molecular formula of ammonia is NH3, okay, and the molecular mass of ammonia is 17. The atomic mass of nitrogen is 14 and hydrogen atomic mass 1, and there are the 3 hydrogen present in the ammonia molecule, so its molecular mass is equals to 17. Clear? And it is a nitrogen and 3 hydrogen attached by the covalent bond, and single electron shared by the hydrogen and the nitrogen, and hydrogen complete its duplet, whereas the nitrogen complete its octet, and it is a electron dot or Lewis dot structure of ammonia molecule. Clear everyone? And in ammonia molecule covalent bond are found. Okay, so 3 covalent bond, it is covalent bond, and it is also covalent bond, it is a covalent bond, covalent bond. The how many covalent bond are found in ammonia molecule? 3, 1, 2 and 3. Clear everyone? So it is what? Dot diagram or Lewis structure of ammonia molecule. Due to the basic nature, it was called also called alkaline air, and basic nature of ammonia is due to the presence of lone pair present on the nitrogen. And how many lone pair are present on the nitrogen? Means ammonia molecule 1 pair. Clear? So due to the basic nature, it was called the alkaline ammonia, and the first prepared by the Joseph Priestley. And who prepared the firstly ammonia? Joseph Priestley. In which year? 1775. Clear? And in 1785 its elements composition was determined by the Claude Lewis Berthollet. Clear? And who determined its the composition of ammonia? Louis Berthollet. And in 1800 its composition was determined by the Davy. Means the firstly prepared by the Joseph Priestley in 1775, and its element composition was determined by the Berthollet in 1785, and structure composition was determined by the Davy in 1800. Clear everyone? And he also proved that ammonia to be a compound of elements nitrogen and hydrogen. You know very well, ammonia molecule is made up of nitrogen and hydrogen. Next topic is your occurrence of ammonia molecule or ammonia compound. You know very well, ammonia compounds are found in the free state as well as combined state. In the free state, ammonia present in a small amount in air and traces in natural water. Okay? And in the combined state, ammonia present in the form of ammonium chloride, and ammonium chloride is a highly soluble. Both ammonia as well as ammonium chloride highly soluble in water. You know very well, ammonium chloride is also a sublimation substance. Means it directly convert into the from the solid state to the gaseous state without passing through the liquid state. Clear everyone? Means the ammonia are found in free state as well as combined state. The pungent smell. The pungent smell which one encounters near a decayed heap of organic matter or a toilet is due to the ammonia. Means ammonia are also found near the decayed heap of organic matter. Organic matter means dead decaying plants and animal, and also present in a washroom of the toilet due to the ammonia. Clear? So it is all about the occurrence of ammonia. Okay, and ammonia are found in free state as well as combined state. Next topic is your preparation of ammonia. Method of preparation of ammonia. It is produced due to the bacterial decomposition of urea. So by the process of bacterial decomposition of urea, you can obtain the ammonia gas. Present in the urine, urea present in the urine. You know very well the formula of ammonia is NH2CO NH2. Okay, and the first organic compound which is synthesized in laboratory, it was the what? Urea. Clear? And the CONH2, it is a urea. When urea decomposes due to the bacterial, then it will form the what? Ammonia. Ammonia plus water and carbon dioxide. So clear? So by bacterial decomposition, you can obtain the ammonia gas. Means when urea react with the water, then it will form the ammonia, water and carbon dioxide. Clear? And the next topic is your form of ammonia. What? Form of ammonia. And the form of ammonia? Ammonia are found in the three forms. First, gaseous ammonia. It is also called dry ammonia gas. Second, liquid ammonia. And third, liquor ammonia or fortis. Okay, liquor ammonia. And the fourth, laboratory reagent. Laboratory bench reagent. Means the form of ammonia are found in the three forms. First, gaseous ammonia. Second, liquid ammonia. Third, liquor fortis ammonia. And the last, laboratory bench reagent. Clear everyone? And the dry ammonia gas, when dry ammonia gas, on applying the high pressure, you can convert the dry ammonia gas into the liquid ammonia. And the liquor ammonia fortis, it is what? Saturated. What is the liquor ammonium fortis? It is a saturated solution of ammonia in H2O. That's why it is also called the 880 ammonia. And this type of ammonia is stored in cold place and the airtight tight bottle. Clear? And the last one is laboratory bench reagent. Dilute solution. It is a dilute solution of liquor ammonia is used as a laboratory reagent. You know also very well कि ammonia we will also use ammonia in this experiment. Okay. So there are the four form of the ammonia. Clear? Next, preparation of ammonia gas general method. By general method, ammonia gas is prepared by warming and the ammonium salt with caustic alkali, with a caustic alkali, slaked lime or caustic soda or caustic potash. Clear? Means ammonium chloride salt is treated with the caustic alkali, slaked lime or caustic soda or the caustic potash. Then you will obtain what? Ammonia gas. It is ammonium chloride. When it is treated with the slaked lime, then it will form salt, water and ammonia gas. It is ammonium sulfate. When it react with the slaked lime, then it will form calcium sulfate, water and ammonia gas. And it is ammonium sulfate. When it is treated with the sodium hydroxide, caustic soda, then it will form the sodium sulfate, water and ammonia molecule. Next, ammonium sulfate, when it is treated with the potassium hydroxide, then it will form potassium sulfate. It is potassium sulfate and also it will form H2O and water molecule. Means it is a what? General method of preparation of ammonia gas prepared by the warming ammonium salt with the bases like slaked lime, caustic soda and the caustic potash. Clear? Get on next page. Next is your laboratory preparation. Laboratory preparation of ammonia. Laboratory preparation of ammonia. Okay. From the ammonium chloride. From the ammonium chloride. And we will use a reactant for this experiment. What? Ammonium chloride and the calcium hydroxide. Dry calcium, it is what? It is calcium hydroxide. Calcium hydroxide and also called slaked, common name, slaked lime. And in this experiment or in this process, taken a dry calcium hydroxide in excess amount. In which amount? Excess amount. Then it will form what? Then it will form salt. It is a salt called calcium chloride and it is water and it is what? Ammonia. Water, ammonia. Means when ammonium chloride is react with dry calcium hydroxide, then it will form calcium chloride, water and ammonia. Okay. So it is a reactant. But what is product? Product is your salt in the form of calcium chloride, water and the ammonia. Okay. And it is what? Arrangement of the apparatus. Arrangement of apparatus for the laboratory preparation of ammonia. It is a round bottom flask, and in the round bottom flask I have taken what? Calcium hydroxide and the ammonium chloride in the 2 ratio 3. Okay, so in the round at firstly I will take what? Calcium hydroxide and ammonium chloride in a 2 ratio 3. Okay, then it will form what? Ammonia gas. First ammonia gas and the water, okay, and also form the calcium chloride, okay, and it is a what? It is a quick lime to a dry ammonia. Here also this bottle is contains the quicklime, means calcium oxide, and the calcium oxide is considered as a drying agent. Okay, so it is the whole process. When the dry ammonia gas, when it will be dry, then it accumulate in the air ammonia gas. Clear everyone? So it is a whole process of the laboratory preparation of ammonia. And also the some points keep in mind at the formation or the laboratory preparation of ammonia. Higher ratio by weight of calcium hydroxide. When you will take the higher ratio weight of the calcium hydroxide, then it prevents loss of ammonium chloride by the sublimation. Okay, higher ratio by weight of the calcium hydroxide prevent, what will be the prevent? Loss of the ammonium chloride by the sublimation. Next point, ammonium nitrate. Ammonium nitrate is not used in the laboratory preparation of ammonia since it is an explosive. Why or not use of the ammonium nitrate? Because of the ammonium nitrate is in the explosive nature and hence may decompose itself. That's why not use the for the preparation of ammonia gas. Clear? And the next point, slaked lime. Slaked lime is used as it is not deliquescent like other caustic alkalis and it is highly economic also. So due to the high economic value of the alkalis, that's why slaked lime is used as, okay, and it is not a deliquescent like other caustic alkalis. So that's why use what? Slaked lime. And the precaution of this experiment, and also the for this experiment also keep in mind the precaution. The flask is tilted. The flask is tilted in a such way that the water formed in the reaction does not trickle back into the heated flask and thus break it. Clear? तो जो भी हम इस अरेंजमेंट के लिए करते हैं प्रोडक्शन ऑफ अमोनिया गैस के लिए, इसमें जो अपरेटस का रिएजेंट होता है राउंड बॉटम फ्लास्क, इसको हम कैसे रखते हैं? टिल्टेड में रखते हैं, स्लैंट में रखते हैं, बिकॉज ऑफ व्हेन द वाटर फॉर्म देन द does not go back to the again the heated bottom flask, otherwise it will break it. Okay, so always keep in mind precaution. Okay, and other drying agent like the concentrated H2SO4, P2O5 phosphorus pentaoxide and the anhydrous calcium chloride not used as ammonia being basic react with them. Okay, only you will use the for the preparation of the ammonia gas. In this process only you will use the for the drying agent of the ammonia gas calcium oxide, not use the like the concentrated sulfuric acid, E2O5 and the anhydrous calcium chloride. Because of the all are react with the ammonia, because of ammonia being a basic nature and react with them, and then it will form the some gives the product. Okay, when ammonia are is basic in nature and H2SO4 is a acid, then it will form ammonium sulfate, and ammonia react with the phosphorus pentoxide, and then it will form the ammonium phosphate. And when calcium chloride react with the ammonia, then it will form the calcium chloride. Okay, addition compound calcium chloride daughter NH3, it is a addition compound. Clear? Got it everyone? That's why only we will use the drying agent for the ammonia gas calcium oxide, not use a H2SO4 and P2O5 and calcium chloride. Clear everyone? Yes. Next, collection of ammonia gas. Collection of ammonia gas. Ammonia gas is collected inverted gas. Ammonia gas is collected in inverted gas jar by the downward displacement of air. It is very important point. Always keep in mind ammonia gas. Ammonia gas is collected inverted gas jar by the which process which the downward displacement of air, because of ammonia lighter than the air. Okay, why the ammonia gas is collected inverted gas jar by the downward displacement of air? Because of the ammonia lighter than the air. The density of ammonia is 8.5, but whereas the air 14.4. Clear? And the second point, ammonia gas is a highly soluble in water, and therefore it cannot be collected over water. And also keep in mind ammonia gas cannot be collected over water because of the ammonia gas is highly soluble in water. So by the downward displacement of water, all the ammonium salt on heating with alkalis give the ammonium nitrate explosive in nature. Clear? So all the ammonium salt on heating, it will give the what? Ammonia gas. Clear everyone? So due to the highly solubility of ammonia gas is collected in the inverted jar by the downward displacement of air and not collected over the water because of the it is highly soluble in water. Okay. Next method is your preparation of ammonia gas from the metal nitride. From metal nitride. What is metal nitride? When the metal is react with the nitrogen, then it will form the metal nitride. So nitrides of the metal, and especially magnesium or aluminium. When the metal nitride of the magnesium or aluminium react with the warm water. Which type of water? Warm water. Then it will form metal hydroxide and also gives the ammonia gas. Okay, so by the metal hydride, when metal hydride react with the warm water, then it will form metal hydroxide and ammonia gas. Okay, when magnesium nitride react with the water, means warm water, then it will form magnesium hydroxide plus ammonia. When aluminium is react with the warm water, then it will form aluminium hydroxide and ammonia. Okay. and this method is a costly. This method is a very costly. Clear? And the procedure, what is the procedure of this method? It is a arrangement of method of preparation of ammonia by the nitrides of metal, and it is a what? It is a flat bottom flask, and in this flask taken a what? Magnesium nitride Mg3N2. Okay, and it is a what? It is a delivery tube, and it is a funnel. It is a funnel. Okay, and by the funnel adds a what? Warm water into a flat bottom flask which contains the magnesium nitride. Then it will form what? Then it will form what? Magnesium hydroxide. Magnesium hydroxide. And then magnesium hydroxide, then it will pass from the delivery tube into the another container, and the other container which contains the drying agent. And also this jar contains the ammonia gas. So before the drying agent, first of all the ammonia gas collected in this block. When ammonia gas is passed from the drying agent calcium oxide, then ammonia gas is collected at the top, mouth downwards displacement, and collected by of the air. And for the drying agent, so which type of the drying agent used for the ammonia gas? Calcium oxide. It is used as a drying agent for drying NH3, as it is basic in nature, does not react with the ammonia, whereas the concentrated H2SO4, P2O5 and the anhydrous calcium chloride is react with the ammonia, then it will form the other product. So that's why only use a which type of drying agent to ammonia? Calcium oxide. Okay. So it is a arrangement. It is a arrangement of the method of preparation of ammonia by the nitride of air metal. Clear? Next process is your preparation of aqueous ammonia. Preparation of aqueous ammonia. What is aqueous ammonia? When the ammonia gas is dissolved in the water, means it is said to be what? Aqueous ammonia. You know very well, ammonia gas is a highly soluble in water. Okay, due to the presence of hydrogen bonding. So it is what? Ammonia molecule. Ammonia molecule, and the water is a highly soluble in water due to the presence of hydrogen bonding. Okay, the rate of the dissolution of ammonia in water very high, therefore back section of water is possible. To avoid this, a funnel is attached to the outer end of the delivery tube with the rubber. Okay, so you know very well, ammonia gas is a highly soluble in water. Okay, yes. Next method is your preparation of ammonia gas by the Haber's process. The manufacture of the ammonia gas by the Haber's process. Okay, and which reactant use in this process? Reactant use nitrogen and hydrogen. And the reactant use in the ratio 1:3 by volume. 1:3 by volume. And the source of reactant The source of reactant is what? Nitrogen gas. Nitrogen gas is obtained by the fractional distillation of liquid of air, and hydrogen gas is obtained from the water gas by the Bose process. So clear? Got it everyone? Means the in this process reactant use the nitrogen, and the nitrogen gas is obtained by the fractional distillation of a liquid air, and the hydrogen is obtained from the water gas by the Bose process. So what is the reaction in this process? Nitrogen when it react with the hydrogen at 450 to the 500 degrees Celsius at 200 atmospheric pressure, and also use a catalyst Fe catalyst or the Al2O3 or the molybdenum, and Al2O3 or molybdenum is considered as a promoter. And what is the promoter? You know very well about the catalyst. Catalyst is a what? It change the rate of reaction, either decreases or increases. But what is the function or the role of the Al2O3 or molybdenum? It is considered as a promoter, and promoter increases the efficiency of catalyst. Means it increases the efficiency of catalyst. Clear everyone? Means in this process nitrogen is react with the hydrogen at a 400 to the 450 or 500 degrees Celsius, and at a 200 atmospheric pressure, and also use a ferrous iron catalyst, and the Al2O3 or molybdenum is considered as a promoter, and promoter increase the efficiency of catalyst. Okay, and it is a purification of the nitrogen and hydrogen is necessary. Clear? Nitrogen and hydrogen, purification of nitrogen and hydrogen is necessary as impurities, carbon dioxide, CO, H2S, because of the position the poisons the catalyst. Means if any impurities like the carbon dioxide, carbon monoxide, hydrogen sulfide in the mixture of nitrogen and oxygen, then it considered as a what? Poison of the catalyst. Poison of the catalyst. Clear everyone? So always before the reaction, first of all, purify the nitrogen and the hydrogen. Okay, and first of all remove all the impurities which contains the mixture ammonia, nitrogen and hydrogen. Next is your condition for the obtaining maximum yield of gas. What are the condition for the obtaining maximum yield of ammonia gas? First, effect of temperature, effect of pressure, effect of concentration. What is the role of the temperature in this reaction? Low temperatures favors the production of ammonia as it is in the exothermic reaction. Exothermic means it produces, evolve the heat. 450 degrees Celsius is the optimum temperature where the yield of ammonia is a maximum. Means always keep in mind, for the formation of a good yield of ammonia, the optimum temperature of this reaction is 450. What? 450. And the next point is the effect of pressure. Where the pressure favors the production of ammonia will be more. Okay. If the higher pressure, then the yield of ammonia gas will be more. And the next point is your effect of concentration. Also the effect of the concentration increases yield when increases the concentration of nitrogen and hydrogen. On increasing the concentration of nitrogen and hydrogen, and then increases also yield of ammonia gas in this reaction. So it is all about the what? Condition for the obtaining maximum yield of gas. Next topic is your physical property of ammonia. Okay, so I have the discuss water method of preparation of ammonia. Now get on the next topic, physical property of ammonia. After that I will discuss chemical properties of ammonia. You know very well, ammonia is a colorless gas. Which type of the gas? Colorless gas. Strong, pungent, choking smell, and ammonia gas has slightly bitter taste. Slightly bitter taste, and the non-poisonous. Ammonia gas is a what? Which type of gas? Non-poisonous. If ammonia gas inhaled affect the respiratory system, and it also, when it's ammonia gas comes in the contact of ammonia gas, then brings tears to eyes. Tears to eyes. And if inhaled in large quantity, then the heart stimulant may cause the death. So it is a very dangerous for the human beings if you have the inhaled in the large quantity of ammonia gas. And the vapor density 8.5 and the air of the 14.4, means the ammonia gas is lighter than the air. Or ammonia gas alkaline in nature. Alkaline in nature means the basic in nature due to the presence of the lone pair on the nitrogen. And ammonia gas easily liquefy at the 10 degrees Celsius by compressing it at a 6 atm. Means you can the ammonia gas convert into the liquid at a 10 degrees Celsius by the compressing it at a 6 atmospheric pressure. Clear everyone? And its BP, boiling point of ammonia, is minus 33.5 degrees Celsius. FP, solid NH3, melts at okay minus 77.7, and solubility in water, highly soluble in water. Okay, ammonia gas is highly soluble in water due to the presence of the hydrogen bonding. Clear everyone? So it is all what? All about the physical property of ammonia. Next is your fountain experiment. Fountain experiment. So what is fountain experiment? By this experiment you can prove the ammonia gas is a highly soluble in water. So high solubility of ammonia gas in water is performed by the fountain experiment. Okay, and it is a what? It is a ammonia gas which contain this bottom glass. Okay, and it is a what? Red litmus solution, this beaker, and it is a what? Dropper, and it is a what? Jet tube. When you press the dropper, then it will what? Then the blue litmus solution, red litmus solution goes into and react with the ammonium gas. Then it will produce the blue fountain. Blue fountain means what? Red litmus solution, when it comes in the contact of ammonia gas base, then it will converted into the blue, and blue fountain. Okay, means water is mixed with the ammonia gas by the dropper when you will press the dropper. Clear? So ammonia gas is a highly soluble in water. Clear? Next topic is your chemical properties of ammonia. Chemical properties of ammonia. First, thermal dissociation. The ammonia on heating high temperature, it will gives the nitrogen and hydrogen. It is a reversible reaction. Clear? And the second basic property of ammonia. Basic property of ammonia is due to the presence of lone pair. Lone pair on the nitrogen. You know very well the one lone pair present at the nitrogen atom 1 to 1 and the 2 means one pair, and it is a three types three covalent bond, single covalent bond. So lone pair is shows the basicity. Clear everyone? Means the ammonia is basic in nature, and the basic nature is due to the presence of the lone pair on the nitrogen atom. Clear? And the aqueous solution of ammonia is called the ammonium hydroxide. Clear? And ammonium hydroxide, when the ammonia is react with the water, then it will form the ammonium hydroxide. On in the dissociation, it will give the ammonium plus hydroxide. Okay? And you know very well, ammonia is basic in nature. So red litmus converted into blue, and the methyl orange converted into from the orange into yellow, and phenolphthalein converted from the colorless into pink. Okay? So means the ammonia gas changes the color in the different indicator. In the litmus, red litmus converted into blue, methyl orange converted into yellow, and phenolphthalein when it react with the ammonia, then the ammonia colorless from the phenolphthalein converted colorless into pink. Clear? Means all are the proofs what indicate the ammonia are basic in nature. Burning of ammonia in oxygen. Ammonia gas, you know very well, ammonia gas is not supporter of combustion. It distinguishes a burning splinter, does not burn in air, and it burns in the oxygen with the greenish yellow flame. Reaction: when ammonia gas react with the oxygen, then it will form the nitrogen and water, and this reaction is irreversible. And the mixture of ammonia and oxygen is explosive and therefore be the dangerous. Okay? And it is this reaction is a strongly exothermic. Exothermic means it will produce the lots of the heat energy. Clear everyone? Means ammonia gas is not supporter of the combustion. It increases a burning splinter. Got it everyone? Next topic is your catalytic oxidation of ammonia. When ammonia is react with the oxygen at 800 degrees Celsius in the presence of catalyst PT, then it will form water and nitric oxide and also heat. And further nitric oxide react with the oxygen, then it will form the nitrogen dioxide, and nitrogen dioxide is a brown gas. Okay? And this nitrogen dioxide further react with the water, then it will form the nitric acid and the nitrous acid, and it is what? Nitric acid and it is a nitrous acid. Means the firstly ammonia is react with the oxygen, then it will form water, nitric oxide and heat. And secondly, nitric oxide react further oxygen, then it will form brown gas, nitrogen dioxide, and last nitrogen dioxide react with the water, then it will form nitric acid and the nitrous acid. Reddish brown, reddish brown vapor of NO2 are seen in the flask due to the oxidation of nitric oxide. And the next point, PT. PT is a catalyst. PT is a catalyst continues to glow even after the heating is discontinued, and since the catalytic oxidation of ammonia is an exothermic reaction. So which catalyst in this process? PT. So catalyst continues to glow even after the heating is discontinued, since the catalytic oxidation of ammonia is an exothermic reaction. Next, ammonia as a reducing agent. Ammonia as a reducing agent. First, reduction of metallic oxide. What is a reducing agent? Reducing agent means a substance which reduced to the others but itself oxidized. So it is ammonia. When it's treated with the copper oxide black solid, then it will give the copper reddish brown solid water and the nitrogen gas. Similarly, lead oxide react with the ammonia, then it will give the Pb plus water plus nitrogen. Okay, means reducing ammonia is as a reducing agent, means reduces to the itself, reduces to the itself and oxidize to the others. And nitrogen is called nitrogen is collected over water in a gas jar. Okay, in this process nitrogen is collected over the water in a gas jar. Okay, the water form collected in the U tube and is tested with the anhydrous copper sulfate. It is a what? Ammonia, dry ammonia taken, and it is a heat copper oxide, then it will form what? Then it will form what? Copper, water and the nitrogen gas. And here the collection of the nitrogen gas. Okay, and water, cold water, and then the pass the delivery tube in this container and the nitrogen gas here collected. Okay, and the water form is collected in the U tube and is tested with the anhydrous copper sulfate, which turns into the blue. Got it, everyone? Next topic is your reduction of the chlorine to hydrogen chloride. Reduction of chlorine to the hydrogen chloride. First, when ammonia is in excess. First ammonia react with the chlorine, then it will form the nitrogen and the hydrogen chloride. And then again ammonia react with the HCl, then it will form ammonium chloride. Overall reaction, ammonia is react with the chlorine, then it will form nitrogen and the ammonium chloride. Observation, the greenish yellow color of the chlorine disappear and the white fumes of the ammonium chloride it will produces. Okay, but in case B, when the chlorine, here in this reaction is ammonia is in excess, but in the second process chlorine is in excess. When the ammonia is react with excess chlorine, then it will form the hydrogen chloride and NCl3, nitrogen trichloride. It is exists in the liquid, highly explosive. NCl3 is exists in the liquid state and it is a highly explosive. Conclusion, chlorine has a great affinity for the hydrogen and ammonia is a reducing agent. Ammonia is a reducing agent. So it is a conclusion of this reaction when the chlorine is in excess, but when ammonia is in excess, the conclusion is what? The greenish yellow color of chlorine disappear and the white forms the white fumes of ammonium chloride. Clear? So it is all about the reduction of chlorine to the hydrogen chloride. Reaction with the acid. Reaction with the acid. When ammonia gas react with the acid, then it will form the ammonium salt. Okay? For example, ammonia react with the hydrogen chloride, then it will form ammonium chloride, and ammonium chloride is a white solid. When ammonium is react with the nitric acid, then it will form the ammonium nitrate. When ammonia is react with the sulfuric acid, then it will form the ammonium sulfate. Okay? And the both are the it shows the thermal dissociation. It shows the both are shows the what? Thermal dissociation. Means on ammonium chloride it will give the ammonia plus HCl, and the ammonium nitrate on the further it will give the N2O plus water. N2O plus nitrogen oxide and water. So when ammonia gases react with acid, then it will form ammonium salt. Aqueous solution of ammonia. When ammonia is react with the water, then it will form the what? Ammonium hydroxide. And the ammonium aqueous ammonia means ammonium hydroxide. Okay, react with the acid, then it will form ammonium salt plus water. It is the aqueous ammonia means ammonium hydroxide. React with the HCl, it will form ammonium chloride, water. Similarly, ammonium hydroxide react with the nitric acid, then it will form the ammonium nitrate and water. Similarly, ammonium hydroxide react with sulfuric acid, then it will form ammonium sulfate and water. Got it, everyone? Get on next point. Reaction of aqueous ammonia solution with the soluble metal salt. With the soluble metal salt. Aqueous ammonia, it is a metallic salt solution. React with the ammonium hydroxide, then it will form ammonium salt and the metallic hydroxide. Ferrous, it is the ferrous sulfate. Ferrous sulfate react with the ammonium hydroxide. Similarly, ferric chloride and the lead nitrate, all are the react with the ammonium hydroxide, then it will form what? Ammonium sulfate, ammonium chloride and the ammonium nitrate respectively. Okay, and also give the metallic hydroxide. When ammonium hydroxide react with the ferrous sulfate, then it will give the dirty green PPT of the ferrous hydroxide. And ammonium hydroxide, when it react with the ferric chloride, then it will give the reddish brown PPT of the reddish brown of the FeOH3 ferric hydroxide. Similarly, lead nitrate give the white PPT lead hydroxide. Clear? So metallic salt solution react with the ammonium aqueous ammonia, then it will give the ammonium salt and the metallic hydroxide as a PPT. Next, similarly, zinc nitrate react with the ammonium hydroxide, ammonium nitrate, white gelatinous soluble zinc hydroxide, and the copper sulfate react with the ammonium hydroxide, then it will form ammonium sulfate, and the pale blue soluble, which means the copper hydroxide. Next topic is your test for ammonia gas and ammonium ion. Test for ammonia gas and ammonium ion. The test for ammonia gas, sharp characteristics order. Okay, ammonia has a sharp characteristics order, turns moist red litmus to blue. moist turmeric paper brown, phenolphthalein solution convert pink. When ammonia and react with the HCl, then it will form the ammonium chloride and dense whiter fume. And ammonia gas turns Nessler reagent, okay, Nessler reagent. Then ammonia gas turns brown with the Nessler reagent K2HgI4. It is a Nessler reagent and it will which color? Convert the brown color. Next topic is your uses of ammonia. Liquid ammonia is used as the refrigerant in the ice plant and used as a non-aqueous solvent. And also main refrigerant is your CFC. CFC means the chlorofluorocarbon. And example CF2Cl2 is a chlorofluorocarbon. And CFC causes the deplete ozone layer and also contribute in the global warming. So day by day CFC is harmful to the environment and also the causes the deplete ozone layer, okay, and also involves in the global warming. When the CFC comes in the contact of the UV rays, okay, then it will gives the CF2Cl radical gas and the Cl radical free radical. Or free radical is a very highly reactive in nature, and this Cl radical free radical is react with the ozone, then it will give the ClO, chlorine oxygen and the free oxygen, and further ClO and react with the O, then it will chlorine gas and the oxygen gas. Clear? Note HCFCS and the HFCS. Both. There are two types of the chloroform. It is a high chloroform and it is also high. Both are the being used as the alternative for the CFC. So in this time it is a what? Alternative of the CFC, chlorofluorocarbon, and it is the less expensive and the less destructive for the what? Ozone. Okay. Yes, next topic is the uses of ammonia. And uses of ammonia, first point, liquid ammonia is used as a refrigerant, okay, refrigerant in the ice plant and used in the non-aqueous solvent, okay. But main refrigerant is the what? CFC. CFC means chlorofluorocarbon, and the example of CFC is the CF2 and Cl2. It is the structure of CF2 and Cl2, one carbon present and the two fluorine and the two chlorine. And the CFC causes what? Deplete ozone layer and also contribute in the global warming. Clear about? Yes. Next topic. Next, when the CFC comes in the contact UV rays, then it will dissociate into the radicals CF2Cl radical and the Cl radical, and the Cl radical is free radical, and you know very well free radical is a very highly reactive in nature, and this Cl radical react with the ozone and it will give the ClO radical and plus oxygen, and further ClO radical react with the oxygen radical, then it will form the chlorine gas and the oxygen gas. Okay. Note HCFCS and the HFCS both are the being as used as the alternative for the CFC, and the hydrogen, carbon, fluorine and the chlorine, okay, and it is what? Hydrogen, fluorine, carbon and the carbons, means both are the alternatives of the CFC, means HCFCS contain hydrogen, chlorine, fluorine and carbon, whereas the HFCS hydrogen, fluorine and carbons only contains. Okay, only one difference is the in this chlorine is present, but in this is a chlorine is not present. Okay, both are the alternative of the CFC. Clear? And the uses of ammonia also used in the nitrogenous fertilizers, ammonium sulfate, ammonium hydrogen sulfate, ammonium phosphate, ammonium nitrate, okay, and also ammonia. When the ammonia is react with the carbon dioxide at a 150 degrees Celsius and 150 atm, then it will form the what? Urea. What? Urea it will form. And also ammonia, uses of ammonia in the formation of the explosive substance. And the ammonium nitrate is a explosive substance, and on heating ammonium nitrate is dissociated into the N2O and water. Okay, so also our uses of ammonia in the formation of explosive substance. Next, ammonium carbonate. Ammonium carbonate used as a smelling salt for the reviving fermented pain person. Okay, ammonium carbonate is used as the smelling salt for the reviving a fainted person. And next, ammonium chloride used in the dry cell and the preparation in the nitrogen gas. When sodium nitrite is react with the ammonium chloride, then it will form the sodium chloride and ammonium nitrite. And ammonium nitrite on heating, it will give the nitrogen and water. So clear? So it is all about the what? Uses of the ammonia gas. Next uses used in the manufacturing of the nitrogenous compound such as the sodium cyanamide, plastic, nylon, rayon, dyes and the explosive. And it is used in the solvay process for the manufacturing of sodium carbonate. Means the uses of ammonia is also used in the solvay process for the manufacturing of sodium carbonate. And next point, use in the manufacturing of nitric acid. Okay, and acid by the Oswald process. Next point, it is also used for the cleaning tiles and the porcelain, etc. So it is all about the uses of ammonia. Next topic is your advantage and the disadvantage of ammonia. What are the advantage of ammonia? Advantage as a refrigerant. You know very well, ammonia is used as a refrigerant. Ammonia does not contribute to the global warming. Okay, and does not deplete the ozone layer. Ammonia uses less electricity. Ammonia leakage is easily recognized due to the its peculiar smell. So it is a what advantage of ammonia. Get on the disadvantage. Ammonia gas cannot be used with the copper pipe in any system. You cannot use ammonia gas in the copper pipe system. It is a poisonous gas, but does not affect the life on the earth because it is a lighter than air. And ammonia has a higher energy cost. Clear? So it is all about the disadvantage of ammonia. I hope you understand the topic, today topic, the compound ammonia, and all about the write the in the notes copy, and after the writing at least one times the revise. Okay, and every topic is important for you for the exam point of view. Okay, ammonia, structural formula of ammonia, Lewis dot structure, method of preparation, laboratory methods of preparation, physical property and the chemical property, uses and the test, and also advantage and the disadvantage of ammonia. So all are the points keep in mind and learn. Okay, and next one we will meet again next topic. Okay, thank you.